Hello and welcome to Assembly Language Programming 8085. In this video, I'll explain how to write assembly language programming and also how to upload and execute the assembly language program in microprocessor kit. First, let me explain sample programs. 8085 has 246 instruction groups to perform a specific task. These instruction codes are called operational codes or op codes. So each instruction, suppose if you want to move the data, so we have an instruction called move, but in 8085, the microprocessor understands only the operational code of this instruction. So each instruction will have its operational code. And instructions are classified into three types. One is single byte instruction, and next is 2-byte instruction and 3-byte instruction. That means they occupy single byte of memory when we upload the program, and some instructions are 2 bytes. They occupy 2 memory locations, and some are 3-byte instructions. In single byte instructions, the opcode and operands are in the instruction itself. Opcode is nothing but the instruction code that tells what type of task to be performed. And operands, the data will be in the registers. So in a single byte instruction is an instruction in which the opcode and operand are available in a single instruction. Example, move A, B. Move A, B is an instruction which moves the contents of B to accumulator. So this is a single byte instruction and its opcode is 78. We cannot give move A, B as it is. It has to be converted to we have to consider the opcode of the instruction and upload in the kit. So move A, B is a single byte instruction. Coming to 2-byte instructions, it has opcode as well as the operand MEI A, 04. 04 is the data. This is the operand, and MEI is an instruction which has its opcode as 3E. This instruction moves immediately the data that is specified in the instruction to accumulator. So 04 is the data that is specified in the instruction. It is moved immediately to the accumulator. So MVIA has the output 3E and 04 is the data. So they occupy 2 memory locations, one for the output and one for the data. Next is the 3-byte instructions. 3-byte instructions are those instructions which contains the opcode as well as the address of the memory location where the data is available. Example, STA 8000. Now, STA is the instruction that is store the contents of accumulator to the memory location 8000. Now, STA has the opcode called 32, and then the address is always given, the lower address is given, considered the second byte, and higher address is given as the third byte. So this is a 3-byte instruction. So the instruction of 8085 are classified into single byte instructions where opcode and operand are specified within the instruction itself. Opcode move, it is a opcode which specifies we have to move the contents from the register B to register A. So the operands are the data is in register B, which must be moved to the accumulator. So opcode and operand are contained entirely in this instruction, and its opcode is 78. Such type of instructions are called single byte instructions. Coming to 2-byte instructions, they occupy two memory locations and they consist of opcode and the operand. So the first byte is the opcode and second byte is called the operand. So here the data is 04 and opcode is MVI-A, that is move immediately the data 04 to the accumulator. So this opcode has hexacode as 3E, so it occupies one location and 04 as the next location. So now these are 2-byte instructions. And 3-byte instructions, as I told you, they contains the opcode as well as the address of the memory location where the data has to be stored or from where the data has to be loaded. So STI store the contents of accumulator to the memory location 8000. Store has the opcode 32, and always when we are writing the address, always we have to take the lower byte as the second byte, lower address as a second byte, and upper address as the third byte. So it occupies 3 bytes of memory. So these are the types of instruction in 8085. Now I'll explain how to write a simple program to move data immediately to accumulator and store that contents of the accumulator in a memory location. So let us start the program. So MVI, as I told you, MVI move immediately A comma 04. That means 04 data is moved to the accumulator. Now accumulator consists of data 04. Now we can store the contents of accumulator STA comma 8500. That means the contents of accumulator, that is 04, will be stored in the accumulator 8500. Now 85, the address consists of the data 04. Now, how to write the assembly language program and how to upload and execute the program. I'll tell you. So start with some memory locations. I'll consider 8000 as a memory location where I'm going to write the opcodes and upload the data. So starting is 8000. As I told you, MVI A04 is a 2-byte instruction, so it occupies two memory locations. So starting is 8000 and 8001. But what is the output for MVIA? It is 3E, comma 04 data as it is we have to consider. Now 8000, we have to feed 3E, 8001, 04. Next is 8002. And coming to this instruction, it is a 3-byte instruction and STA consists of 8002 must contain the opcode of STA stored accumulator, that is 32. And then as I told you, next must be the lower address 00. Next is the higher address. Now we have to feed this program in this memory location and then execute it to check whether the 04 is in the memory location 8500 or not. I'll explain the procedure to upload the program and execute the program. The step one for uploading is in the microprocessor kit. You can say the microprocessor kit consisting of several keys as well as the alphanumeric characters. So first, what you have to do is first you have to go press examine memory. First step is press examine memory. Then type 8000 and press next. Now you can enter the opcode in the 8000 memory location, that is 3. Once you press the next, it will be moved to the data. Next, again press next. Then it will change the address to 8001 and then you type the data as 04. Then again type next. Then the address will be incremented by 8002. Then feed 32 there. Again press next. Then address will be incremented by 8003. Now if you 00. Next you again press next. it will be incremented to 8004. Then you fit the 85 there. Then you press the next, and then it will show 8005. Here you press reset button. So once you finish this, then you have to go to next memory location. So the program ended at 8004. We have to go to next memory location and press the next, press next 8005. There you press reset. Now to execute the program, you have to press go, then give the starting address of the memory, go 8000 and press execute. Then we can see the letter E, that means the program is executed. Now we have to check the answer in 8500. But that again, examine memory, press examine memory 8500, press next. Then you can see the answer 04 in 8500. So this is how we have to upload the program. I once again repeat how to upload the program for these two instructions, MVI A,04 and store the contents of accumulator in 8500. The first thing is, first we have to write the ports of the instruction. So start with the memory location 8000. Then I can write, go to examine memory. First press examine memory 8000, press next, then type 3E, then press next. It will automatically increment it to 8001, type 04. Press next, then it will be incremented to 8002, type 32. Next, again, press next, it will be incremented to 8003, so type 00. Press next, again, it will be incremented to 8004, type 85, and then press next and then press reset button. Now the program is uploaded. We have to execute it. To execute the program, go type the starting address of the program, that is 8000, and press execute. Then you can see E on the kit. Once it is executed, you can check the answer. But again, once again, where is answer? Answer is in the memory location 8500. To go to 8500, press examine memory, and then examine memory, type 8500, press next, then you can see the answer 04. So this is a simple program. So let us watch the video for this program. The next program is another simple program. So we have seen two instructions, that is how to move the data to the accumulator and how to store the data from accumulator to memory location. Now I'll use one more instruction called complement the contents of accumulator. That means I'll take some data and complement it and store the result in a memory location. So let us start the program. So again, we can use this instruction MVI A,03. Now accumulator, we are storing the data 03. So 03 is hexadecimal. You can write in the binary format as 0 can be written as 000 and 3 can be written as 0011. Now I'm using the instruction called CMA. CMA is an instruction which complements the contents of accumulator and stores the result in accumulator itself. So complement. Now A consists of 03. If you complement it, so complement of 0 is 1, 1, 1, 1, and 1, 1. Complement of 1 is 0, 0. So this is nothing but your F, and this is nothing but 8 plus 4, that is CFC. So next, accumulate. Now the accumulator consists of the FC. We have to store this in the memory location 8500. So first I have taken 03 in the accumulator, and then I complemented the content of the accumulator by using the instruction CMA. It is a single byte instruction. You can see and store the contents of accumulator in 8500. So 8500 must contain the answer for FC. So this is a single 2-byte instruction. This is a single byte instruction. This is a 3-byte instruction. Now let us write the outputs for this program. So it will start with 8000. As I told you, MVI A is 3E, comma 03. So 8000, 8001. Again, write 8002. CMA. The output for CMA is 2F. It is a single byte, so it takes only one memory location. Next will be 8003. Now, because this is 3-byte, it will take 3 memory locations. So in 8003, type 32 and lower address 00, upper higher address 85. So this is a program we're going to feed and check the answer in 8500, and we must get FC as the answer. And the procedure is again same. What we have to do is first examine memory 800. First press examine memory 8, type 800, and then type next. You can get it at 3E. Next, it will be incremented. Then type 03. Next, or 802, it will be incremented to 802. Type 2F. Then again press next, and then type 32. Again press next, type 00. Again type next, press next and type 85, and then press next, and then so 8003, 4, 5. So once you get 8006, here you have to press reset. So to execute the program, again go starting address of the memory, type 8000 and press execute. And then to check the answer, again examine memory. You can write examine memory 8500. You can see the answer FC. So this is a program to find complement of the accumulator. This is the second program. The first program consisting of 2 instructions, and next we have used 3 instructions. Next, we'll write one more program to decrement the contents of accumulator. In the previous program, we have seen how to complement the contents of the accumulator. And here, the accumulator, I will take 08 as a number. And if you decrement means it will decrement by 1. So first write the equivalent of 0800, and 8 is 100. So if you decrement means it subtracts 1. So it becomes 000. Here 1, it is 0. So it becomes 10 minus 1. 1. This is 1. This becomes 1, and it becomes 0 because we are pouring 1, 2 here. So it becomes 1, 1, 1, 0 minus 1. So it is nothing but 0 and 7. Now let us write the program again. MVI A, 0, 8. Now, the instruction for decrementing the contents of accumulator is DCREA, decrement the contents of accumulator. Now, store the contents of accumulator in memory location 8500. Again, we'll write the output for this 8000. MVIA is again 3E. Now, the data is 08, so 8108. 8002. Decrement A is 3D output for this. And then 8003, it is a single byte instruction, so it takes only one memory location. 8003 store is 32 and lower 00, 2004, 8005. Now, if you want to check the answer, the procedure of uploading and execution is same, and you can also check the procedure for checking the result is also same. X is the increment. So now we have seen the decrement, the same program, we can use for the increment also. Suppose accumulator, we take 03 now. So 0000011 plus 1. Increment means it adds 1. 1 plus 0, 0. 1. 1 plus 1, 0. 1. 1 plus 0, 1, 0. 0, 0, 0, 0. This is nothing but 0. This is 4. So we get 0, 4. Again, the same thing. MBI A, comma 03. INRA, implement the contents of accumulator and store the contents of accumulator in the memory location 8500. So again, start with 8000. MBR A as a total is 3E. Data is 03 and 8000, 8001. 8002 INRA is 3C, output for INRA, and 8003 32 0085. Now the processor for uploading and execution and name of the result is same. So these are the simple programs, assembly language programming in 8085. So I have shown the programming with 3 different types of instructions in 8085, that is single byte, 2-byte, and 3-byte instructions. So here I have used only the 2-byte and 3-byte instructions. So if the 2-byte instruction consists of code and operand. Code for MBI is 3 and operand, that is data is 04. And 3-byte instruction consists of code as well as the address of the memory location where the data is there or the data has to be placed. So 8500, because we are storing, we have to place the data from accumulator to 8500. So the output for STA is 32. And when giving the data address, we have to give the lower address first 00 and then the higher address next. So 8002 32 type, 8003 00, 8004 So this is a simple program. In the next program, I have shown how to write using 3 different types of instructions, that is 2-byte, single byte, and 3-byte instructions. So I have shown 3 programs. One is how to complement the contents of accumulator, and then how to decrement the contents of accumulator, and then how to increment the contents of the accumulator. So this is a these are the simple programs. I hope you all understood. I think I once again repeat how to feed the program. I think so we have to write the opcodes starting opcodes in the memory location at that examine memory, starting address of type, starting address of the memory, press next, and then start reviewing the opcodes and the values. So you can use next option, and then once you reach at the end of the program, go to the next memory location and press reset to execute the program. Press go and start giving the starting address of the program, and then press execute. And you can see E on the microprocessor. Once it is done, you can examine the result by pressing examine memory and then type 8500 where the result displays that address it will and press next, and then you can view the result. And here I have used 8000 and 8500. In some cases, it may be 2000 or 2500. Memory location are in some cases it can be 5000 or 5500. The memory varies from kit to kit. Please do watch its manual for the address. In this case, the 8000 and 8500 are meant for the users. So that's why I have used these two memory locations for uploading the program and for uh, viewing the for uploading the data as well as for the storing the result. I hope you all understood. Thank you.